Welcome to Shift, a college admissions ACT, SAT, and CLT podcast for a changing world. I'm Tyler, the founder of Achievable, and we have an affordable ACT course that includes everything you need to ace your ACT. A full textbook, tons of questions backed by our memory-enhancing algorithm, videos on key topics, a built-in study planner, and full-length practice exams. You can get a free trial by going to achievable.me, and if you like it, use the code podcast for 10% off at checkout. Now, let's get started. Today, we've got Ed Antoine from Antoine Education. And Ed, I'd love if you could introduce yourself.
Sure. Thanks, Tyler. My name is Ed Antoine, and my company is Antoine Education. I'm based in Brooklyn, New York. I've been teaching SAT and ACT prep for more than 20 years. And that's most of what I do, but I also help kids get into the very selective public high schools in New York City, running an SHSAT course.
Yeah, fantastic. So today we're going to be talking about what makes hard SAT math questions hard, right? And I mean, this probably applies really to all kinds of math questions, whether it's on the SAT or not. But I'm curious, yeah, how do you kind of start this uh, conversation with your students?
Well, one thing is, it's interesting. I'll kind of frame it a little bit. I mean, I think that there's a difference, say, between, what makes a hard math problem hard versus what makes an ACT math problem hard. And the thing is that the ACT goes much further in terms of their coverage of math. So you're more likely to be in a situation where you just haven't learned the math yet. So it's hard because you've never heard of it. Whereas the SAT math, it's the scope is a lot more limited. So they'll take the same content area and they'll try to make a harder problem without expanding the content area it's being covered. So that's kind of what I say, like, what makes it hard? How do they take a quadratic equation and make the problem so hard? And I think that, even when I say that, I realize that for people, if you don't know how to solve any quadratics, then any quadratics is going to be hard. But what makes it, particularly hard? How do they ramp up the level of difficulty? And what I feel is that they kind of they create these situations where you have what I call a narrow path to the solution. It's like,
Right.
You can't see where you're going. All you can't see the solution. You start off with the problem, and I think that's one thing that students, like most students, they want to read the question and pretty much know what the answer is, even if they have to do one or two calculations. They want to kind of know where they're going. But you can create a question. The College Board will create a question where it's very hard to see where you're going. The only thing is the logic. And again, I'll often say to people, I consider the SAT as much a logic test as any other kind of test. So all you can do is say, well, given the information they gave me, then this must be true. And given what I just determined was true, then this next thing must be true. And given the next thing, and it's like every time they add a step, they know that they're going to lose a couple, probably a couple of tens of thousands of kids, right? They're going to lose some people. So it's like they just keep giving you more hoops to jump through, but the hoops are like logical constructs. Like, do you know, based on this, what has to be true?
Yeah. So is there, I don't know if you like have examples in front of you or just kind of example ideas, but like, can you give sort of like some kind of, I guess a way of like demonstrating this concept?
Yeah, I was thinking about this, and since we don't have, I can't draw out a problem, but I think a very classic example would be, and I looked at a problem from the Blue Book, test 6. In fact, the last question, test 6, the last math question, number 22 in module 2. And it's a perfect example of this idea where all they give you is like the quadratic equation in standard form, ax squared plus bx plus c. And you've got to start with the abstract form of the quadratic equation. And then they just tell you two facts. And what's interesting is essentially they're telling you where the roots are. They're telling you where the roots are. And you've got to say, well, if I know the roots, Like, what do I know is true just by knowing what the roots of this equation are?
Right.
And then you've got to take that as far as you can go. And it's interesting because I did it, the way I don't know how detailed, given that people can't see it, but how detailed you want to go. But the way I do it is, and one thing I teach kids all the time, is to say with quadratic equations, you're trying to get ready for these hard questions. So you've got to know a whole series of things that must be true. So if they give you a quadratic equation in standard form, one thing I say is, like, I draw a parabola on the board, and I say, look at the key things. There are only a few things they're going to ask you about. They're going to ask you about the roots. They're going to ask you about the y-intercept. They're going to ask you about the vertex. And they're going to ask you whether the parabola opens up or down. And, and this is like my I try to sell this, is like, if you know all those things, there's no way they can ask you a question you can't answer. You're going to be able to answer any question if you focus on the fact of all there is to know, or not all there is to know, but the things they're most concerned about. And in this particular problem from the blue book, you essentially have to say, like I say, well, okay, you got it in standard form. Where's the vertex? So you can start with that. And you need to know how to manipulate the constants to find the location of the vertex. Negative b over 2a is going to give you the location of the vertex. Now, in this particular case, again, since they didn't give you, and stop me if I'm getting too abstract or don't think it'll translate in terms of the audio, it's just, they don't tell you what a, b, and c are, but they do tell you the roots. So again, you have to say, okay, I know where the roots are, and I know the vertex is midway between the roots. So I actually know numerically where the vertex is. And I also know that negative b over 2a is the coordinate of the x value of the vertex. So again, that's kind of what I meant by this. So there's this one thing that you know is true, and you start there and you see how far you can push it.
Yeah. And I mean, I think that thinking about kind of what you're saying, for me, I think of how basically you've got to kind of understand the potential scope that the questions could ask you things about, and then know how to, like, know what that is in, like, a well-defined way, and then, like, know the tools really well, or the processes, or whatever you want to call it, right? Like, and then you can try to kind of back out into, like, well, what is this question really asking? It's kind of like thinking like the test maker a little bit.
I think it's very much like thinking like the test maker, because what I tell them is, for whatever reason, and I don't claim that I know the reason, they've decided that certain things are important for you to know. And one of the things that's important, again, for this example of quadratics, is the location of all these key features of the graph parabola. And if you feel stuck and you start thinking about, well, these are the things I'm supposed to be able to figure out, chances are, along the way, and a lot of times they tell them, keep pushing it as far as you can push it, then reread the question and see if you have the answer.
Right.
Because a lot of times you just get to your logical endpoint, like, okay, there's nothing more I can figure out. But then you look back and you reread the question and realize, oh, I now have all the information I need to answer this question. So it is thinking like the test maker, like, what are the things the test maker is concerned about? And again, I talked about quadratics. They do the same thing with other equation types. Linear equations, exponential equations. And I think the new digital tests, they've really ramped up the way they test your familiarity with the form of a basic exponential equation, and whether or not you really understand, like, kind of like what's going on with an exponential function. And I think I think of this in two ways. One is just like what it means, and the other is, if you could just get it, like this happens over and over again for different types, if you can get it back into its standard form, you're probably going to be able to answer the question. Like, so I'll have an exponential and I'll say, just take whatever they gave you and get it back into a standard form. Once it's in standard form, you're probably going to be able to answer the question.
Yeah, no, that's a really good tip. I mean, I remember, obviously this is a little bit different because it's for the GMAT, but I remember when I was taking the GMAT, there was some question I was like, what is, 1,000,001 X minus one, right? Times like 999999 X
Yeah,
uh plus one or something like that. And I just looked at it and I was like, how the heck am I supposed to solve this? Well, if you simplify it, right,
yeah,
and I forget exactly the solution, but basically all that was a really scary looking version of a much simpler
yes,
equation, right? Where it's just like you got X plus one and X minus one, you multiply them together in brackets, and what does that end you up with? And so it's kind of like I don't know if disguising problems is the right way to put it, but like in order to, like you said, make things more difficult without expanding the scope, they do some little tricky stuff like that to kind of make it a little hidden.
I tell students that they try to intimidate you. And I think it's
Mm,
true. They try to, you could use the word obscure. They try to obscure the simple math, like that they're consistently testing. They're always keep testing the same thing, but they'll try to obscure it, and they try to obscure
mhm.
it with things that scare you, so that you'll be intimidated
Right.
and you won't try. Um, I think a really good example of that, again, it was a Blue Book test. I believe it was test Blue Book 4, and I don't remember the exact question number, but it's one where they give you. Oh, actually, I know it was almost certainly it was question number 21. I could check, but where they have this whole thing about this electrical flux through a plane, and I've been doing this long enough that as soon as I saw this, I was like, "That's the distraction. That has nothing to do with this problem." Now, again, I wouldn't expect your average teen, 17-year-old under stress to get their best SAT score is going to be that calm about it. But I just had a
Mhm.
feeling. I'm like, there's no way this physics has anything to do with solving this math problem. So I was able to
Right.
very quickly focus on, like, okay, they have an area, and it's all related to the ratio of the area of these two. There were two squares, basically.
Mhm.
But when I'm prepping kids for tests, that is another way. That doesn't fit quite the definition I was talking about before about how you make a problem hard, but that is another
Mhm.
way that they make you miss, I would almost say. Like ways to
Mhm.
keep you from just focusing on the math that they test.
Yeah. Yeah, that makes a lot of sense. What are some other sort of things that you've noticed, just like other ways that they can make hard problems harder on the SAT?
Well, this is one that I really kind of like is the way they work with linear equations. Because linear equations can be super simple, right? And their equation of a line. Almost every student knows, y equals mx plus b is the equation for the line. And one of the first things I talk to them about is, I try to get them to define the slope for me, and I tell them, look, I'm going to be very, rigid. I have a definition of the slope that I want you to memorize. But the reason isn't just because I'm annoying, which may or may not be the case, but it's also going to be very effective for hard linear equation. And they're not even, I define it as there's linear equation and then there are linear models. And when you model a real world situation with a linear equation, you want to look at it a certain way. And so I insist that they, memorize, that the slope is the amount that's on the y-axis, the amount that's on the y-axis changes when the x-axis changes by 1, or the
Right.
change in y when x changes by 1. But then I take them to the model and I say, now we're going to repeat this exact same thing, but we're not going to say
Hmm.
the amount that y changes when x changes by 1. We're going to say, the amount that the height of the child changes when their age changes by 1. And I've
Right.
seen on some of the most you know, difficult by placement, but also difficult by experience of seeing kids try to answer them, that they literally will have a model of some, silly situation that seems complicated. But if all you do is say, okay, number one, what's the slope? because I tell them a lot of times, if you're confused on a problem that's a linear equation, figure out what the slope is first. Figure out, because that's probably the root to the solution. Figure out, if it's a model, figure out what the slope means. Like, what's the relationship between what's on the y-axis to what's on the x-axis? And once you actually know that, and I've seen it happen so many times, once you know that relationship, the answer is almost always obvious. Like, it's clear. Like, once you get clear on the situation, the answer is usually the slope or the y-intercept. It's the starting position or the zero, or it's the rate of change. But until you understand that's what they're looking for, the problem can be quite tough.
Yeah, yeah, exactly. And that's, I think, something that, the SAT kind of has to do because they're keeping the scope so narrow, right?
Yes.
Like, which, at the very least, you have to study sort of a smaller subset of things.
Yes.
But you also need to get well versed in trying to kind of decipher problems.
Yeah, I mean, I think it's clearly a choice. It's clearly a choice to write a certain type of test. And I mean, that one example of, I kind of like looking at the linear equation questions in a test and seeing how they go from the simplest to the middle to the hardest. And I think there's some sense in which, okay, that's reasonable. Like, sure, you're supposed to, some people just know the basics. Some people have a middling understanding, and some people really know what it means. And again, there's a degree to which that's knowledge, or you could say
Mm-hmm.
it's your strength in logic.
Right. Yeah, that makes sense. Any other kind of thoughts on this topic? Like anything else that you wanted to make sure we covered today?
Well, I think it is important to say, like I kind of alluded to it a little bit in the beginning, is that I'll say I've said all these things that I think make SAT problems hard. But if you don't know, like sometimes we'll describe the test as it's a logic test based on a few math facts. But if you
Hmm.
don't know the math facts, you can't do the logic. So I don't want to downplay the fact that for your average student walking to the SAT, you may have some math to learn. You may have some,
Hmm.
and in the new edition of the test, they've added more geometry. So there is more geometry to learn than there were in previous versions of the test. But again, even in that situation, so you do need to learn content. But once you've learned the content, don't think they're going to go beyond the scope. They're not going to go beyond the scope of that content. They're going to increase the difficulty of the logical process you have to go through to get to the answer. And if you can keep that
Right.
in mind, then you can kind of keep your head about you and and solve almost all the problems.
Yeah, exactly. Yeah, and I think it's also just like for me the it's that point of view of like how did the test makers write this and like what are they trying to ask that has really helped me when I've had to take these kind of tests, right? Even as going into more advanced ones like the GMAT, like I think that once you start to kind of be like approaching each problem with sort of a curiosity about it, right? Then I think it helps you like have the right frame of mind.
Well, to play off of that, I think one thing is I'll tell students sometimes you should be able to think of these problems forward and backwards. And that is and someone who's curious about something will look at it forward and backwards. And if you understand that that's kind of what they want you, that's where they want you to be in terms of your understanding. What is every little piece? If you have an equation in a different form, like, well, here's one example with the with a y equals mx plus b with your basic linear equation. I'll say, what's m? Well, it's the slope. I know what the slope is. What's b? I know what b is. It's the y-intercept. What are x and y? And then they'll just stop for a minute, like they hadn't thought about what x and y was. But there are
Mhm.
difficult SAT problems that hinge upon your understanding that x and y represent any potential coordinate pair on that line, and you have to just use that bit of knowledge. And if you're more curious, the more curious you are, the more you think about the forward and the backward of a problem, the more likely you
Mhm.
are to be ready for that question. And I tell students all the time, we can prep you to like a 780, but if you're going to get an 800, you may have to be a little creative on test day because they may have pulled another trick on. Like I feel like I literally say I think they have this like bag of tricks, and they pull one out for every
Right.
test. They have your standard stuff that gets you to a 780, and then they throw from their bag of tricks as something that you're only going to see, once every decade to see who can handle it.
Right. And also at the same time, wouldn't be too upset about a 780 either.
Yeah, yeah. Most kids wouldn't. Luckily, well, that's why I feel free to say that because I understand that most kids are gonna be like, "Whoa, she's fine. All right, if I can get a 78, I'm fine." You know.
Yeah, yeah. Yeah, and then, there's always those kids that want to get an 800. I remember there was someone in my high school who got, this was back when it was a 2400 point SAT. They got a 2390
Yeah,
because they got a 790 on the essay, which is now gone. And they went back and did the whole thing
they
again.
did it again. It's funny.
I was like, why?
like why exactly? Well, why is a good question. But I had a student years ago who back when it was 1600 and we finished a session and she told me a friend of hers had gotten a 1600 and her friend's dad said to her, "Oh, that looks good. Can you do it again?"
Wow.
So
That's a lot. I would like want my kid to focus on other stuff, right? Go work on your extracurriculars, but whatever.
yeah, yeah, it was an interesting choice on his part. I've wondered why he would have said that to her. I didn't know the girl. I didn't know their relationship, but I assumed he had some whatever. It was probably part of the dynamic of their relationship, always
Yeah, I
challenging
think
each other.
so. Well, cool. Well, yeah, I think that this is a really good, like, I think we've got some good tips here for, hard SAT math questions and how to solve them. And then I just wanted to ask if there's anything else we didn't cover today before we wrap up.
Um, no, I think I feel like we covered a lot, in terms of content, in terms of, as you mentioned, your term curiosity, like just this idea of being flexible and being interested and, and I guess I'll just reiterate that don't let them intimidate you. If something looks complicated, just take the next step. Like if this is
Mhm.
true, what else has to be true? Do that as many times as you need to, and then reread the question, and more than likely you'll know the answer.
Yeah, fantastic. Well, thank you so much. This has been Shift, a college admissions podcast for a changing world, hosted by Tyler from Achievable with Ed Antoine from Antoine Education. And you can get a free trial of Achievable's ACT course by going to achievable.me and use the code podcast to get 10% off.